Hey guys, and welcome back to the Beginner's Guide to Restoring Early Tube-Based Black and White Televisions. Well, in the last installment we had done a deep dive into the horizontal deflection circuit, flyback transformer, damper tube, and how that all works together. I wanted to start out this installment by reviewing that circuit, a few key concepts, and how that's actually realized in the set, and some components to be aware of. One of the important things about how this circuit works is when the sawtooth that's driving the grid at 6BG6 gets to the end, we get to the far right hand side of the screen and it cuts off that tube and the magnetic field starts to collapse. They designed the circuitry, chose these component values such that this will self-resonate, start ringing at a certain frequency that will cause the magnetic field to initially flip and send the beam to the opposite side of the screen, and then the 5V4 starts conducting and dampens out the oscillations. Well, the reason that works is normally the 5V4 is conducting and it's supplying power back around to the flyback, but that initial ringing pulse is the opposite polarity, so this 5V4 actually turns off. Well, this still needs power to keep operating. We still need a positive voltage on the plate. It took a little bit of digging and some helpful comments to fully realize how all this works. These two capacitors, the 0.05 and the 0.035 on either side of the linearity coil, those store energy such that when the 5V4 is cut off, they still have some charge in them, and that completes over to the plate and keeps it going for that brief retrace interval, which is 7 microseconds or something to that effect. Those are pretty critical capacitors, as are the values. 0.035, which is an oddball value. I use 0.033, should be close enough. Even for back then when these were made, 0.035 was kind of an oddball value, but I assume they chose that, again, because of that key resonant frequency in conjunction with this linearity coil. So try to get as close to that as you can. Also, a good idea to use polypropylene film capacitors for these, like a Sprague orange drop, because these see some abuse, I guess is one way to put it. When this does that magnetic field reversal, we get that jolt of energy going from the right side, get us back to the left. That hits the circuit hard. The damper tube gets hit hard as well. A 5V4 is not a proper damper tube like came out later, but it's what they had at the time. They seem to work well enough, but later on they came out with tubes like the 6W4, the 6AU4, 6AX4, and so on, because the voltage pulse, the peak inverse voltage when it does that flip, can be over 1,000 volts. You don't want to probe this with your meter or your scope unless you're sure it can handle that. And you want to make sure all the wiring, everything is really sound in this area. And something interesting about this too is all these other tubes, 6SN7, 6BG6, they're all 6-volt tubes. All the filaments are wired in parallel, except for this guy. It has dedicated filament windings that go over to this transformer. They have a dedicated secondary winding just for that tube and nothing else, and it's heavily insulated because of that heavy punch. Later 6-volt, 12-volt damper tubes that had the separate filament and cathode were designed to operate in parallel with the other tubes, and they had a really high peak inverse voltage handling capability, over 1,000 volts, over 2,000 volts, so they could be wired in parallel with the other tubes. But even so, I've seen sets that use those damper tubes, and they still, sometimes even just a separate transformer entirely just for the damper tube, because of the voltage spikes. They can break down insulation. So make sure you got a fresh tube in there, make sure the wiring is sound, the insulation hasn't degraded, and use some high-grade caps for these two guys. Furthermore, because it's such a critical circuit to the whole operation of the set, I often will just shotgun all these components. Often this 100 ohm cathode resistor on the horizontal output tube will be drifted of value. Typically they drift higher. You want to make sure these caps are good quality as well. And just in general, not only do I want to use parts that are on spec but are robust, so I may even increase the wattage rating, that kind of thing. I use metal film resistors. Yeah, they have some parasitic capacitance and inductance. For frequencies this low, it's not an issue. I was just reading a data sheet, and it's set up until you're above 100 megahertz. You really don't need to be concerned about using metal film resistors, so that's what I use. Or metal oxide was also a fine choice. I don't like to use carbon because it drifts with temperature, whether it's carbon film or carbon comp. I want my horizontal circuit to be stable. Likewise for the vertical. I don't want to have to get up and adjust the horizontal hold. So I went ahead and recapped this whole area. I did not use orange drop or polypropylene film caps because I don't have any on hand, but I should. And there's that 0.035. I used a 0.033 in particular. Another one that's pretty critical is this guy here, because that's works in conjunction with this coil. That's at the free running frequency. They actually have it on a separate little terminal strip just from one capacitor. Again, I used a film cap. Often those are mica. You might want to use mica or C0G because you don't want that frequency to drift. I used film because that's what I had on hand, and it's kind of a large value in this set. I believe that was a 0.015. So a little bit a 15,000 picofarad mica cap could be a little expensive, but you should be able to C0G ceramic, that high a value, might be a little tough to get as well. So use film if you have to, but ideally that would be something even better. Polystyrene, which maybe only one maker makes anymore, unfortunately. That's the problem with this hobby, is our choices of components sometimes are a little tough because things come and go depending on what's currently being manufactured. Companies stop making stuff like axial capacitors, for example. But we do what we can, so we use yellow caps and whatnot. So do the best you can, use the best parts you can. Sprague Orange Drop are fantastic caps. They're bigger, they're more expensive, but at least they're still made. So we got the horizontal looking a lot better. The width has come in, the horizontal linearity is a lot better. And the reason we started down this path was, well, I've been fighting a vertical issue from the very beginning. And we've made some incremental improvements in it. That led us to the horizontal circuit because there's a boost voltage generated by the horizontal circuit that's used in the vertical circuit, in particular the height control. That helped a little bit, but not that much. So here's me adjusting the height control. It's minimum height, maximum. It should be off the top of the screen and the bottom of the screen at this point. Here's the linearity control. In order to get good linearity, meaning all these squares are equal width. Remember, I have the TV on its side, so the vertical is this way. So that's not going to cut it. So let's circle back, review the vertical, and see if there's anything we missed. Now, there just isn't that much to it. It's these two tubes, vertical oscillator, vertical output. We've replaced the paper caps. We rebuilt the vertical integrator, but really this sink and the integrator isn't needed when we don't have a signal applied. And without a signal applied, we still don't have enough width, so we can just ignore all that sink stuff. Problem has got to be down in here. Or potentially we have a bad yoke, but I don't know if I've ever seen a bad yoke, but from photos of what I've seen a bad yoke looks like, it would be dramatic. There'd be keystoning, would have no vertical deflection. It's just two coils in series. If it's open, we'd have no vertical deflection. If it's shorted, it would be grossly distorted. I've tested the tubes. I've swapped out the tubes. We replaced the caps. I've checked the resistors. If you go through the troubleshooting guide, they tell you a few things to check. Check those 2 tubes. And check some capacitors. That's where I think I missed something. Remember, there are 2 electrolytic can capacitors on the top side of the chassis. There and there. And I replaced 2 of them. That's one of the first things I went after was a cathode bypass cap. Which, I think is that guy. And I replaced that guy. That would be this 50 microfarad. And that 20 microfarad. I missed one. There's a 3rd electrolytic over here. And what does that go to? That goes to one side of the height control. So, let's go after that guy. It's kind of buried down in there. I don't know how I missed that, but it's right there. It's right where that 150K and that one wire goes to. That lug right there. So let's clip that out of circuit and tack in a replacement 20 microfarad and see if that gets our boost up. I know it's a cliche. Well, it's not a cliche. You hear it over and over and over again. It's the caps, it's the caps, it's the caps. Because it's usually the caps. Sometimes it's the tubes. Sometimes it's an open resistor. But usually it's caps. Now you might be wondering, well, what about troubleshooting? Why didn't we detect the problem going through and probing and this and that? That's the trouble. When things are flat out not working, when there's a gross, obvious problem, like there's no image, there's no sound, those problems are generally really easy to fix. It's going to be a part that's completely dead, it's completely open, it's completely shorted. We've taken care of that stuff. Now we have the subtle problems. It's mostly working. We do have vertical deflection. It's just maybe 20-30% low. Those could be a little bit harder to pin down because it's not a part that's completely bad. It's just a little bit degraded, probably. So sometimes you do resort to just substituting parts. Or, yeah, I could remove everything. Well, here's the thing. We've tested caps. At full specs, they're all bad. And that's the trouble with, well, it's the trouble with troubleshooting these, is a part can test bad at full spec, but still work okay in the circuit that it's in. That's why you see a lot of guys, either because they have experience and they know that they're just going to shotgun replace all the caps, or they're newcomers and they've just been told that it's always the caps and they go through and replace them. As long as you don't make a mistake, I gotta say it's not a bad move, because some of these problems, if you try using a scope, using a meter and all that, and it's a subtle problem, you might not be able to detect it, or you'll have a hard time detecting it. Alright, so let's clip out that resistor, clip out that wire. That wire's got plenty of length on it, so we can bring that out here, and we'll swing this resistor. The set is turned off. We'll swing this resistor out here. Going to strip a little bit of wire off of the end and tack them together, and then tack a resistor in place. Or use alligator clips. Obviously not a safe way to do any type of repair, but for a quick substitution. Trying to make this somewhat educational, just so we can clip something in and see the effect. Because I could have just, what I would normally do for customers, I would just go through and shotgun and replace everything, and then do some troubleshooting, as at least one of you suggested in the comment sections. Yeah, that would be my normal approach, but that's not very instructional. And I know some of you like to see work, so this is work. I clipped out the resistor lead and the wire, stripped the ends off, and now I'm tinning them so I can tack them together. If you don't tin the ends, by tinning I mean heating up and putting a little bit of fresh solder on them, it's hard to get them to get together, especially when you only have 2 hands to work with. And of course, when I put this third lead on, those 2 may come apart, but if I'm quick and I'm lucky, they won't. Or again, I could use alligator clips and test leads. I need to ground this somewhere too. You know what? We have an unused grounded lug here, so I'm going to tack in the negative on the cap here, and then I'll use an alligator clip test lead to connect the positive side. And this is all very temporary, just to see what effect it has. 22 microfarad, 450 volt cap. The original was a 20. I'm not sure what the voltage rating is, but electrolytics, typically 450 is the highest voltage rating you can get, and I'm sure all the caps in this set are 450 or less. So that should be fine. And here's a lead I can use. So we clip this and we clip that to where the other one was. Could we have put this in parallel with the existing cap? Maybe. If the existing cap has gone open and it's not doing its job, yeah, a quick substitution, yeah. But if it's leaky and it's dragging it down, putting another cap in parallel with it is not going to remedy that situation. Okay, let's see what effect that had. Alright, so it's warming up. Let's see what effect that had. What do you know? That took care of it. That took care of it. Still not as much height as I expected I would, but that's enough. Remember, it's a 4:3 aspect ratio. With the mask and all that, you wouldn't want this going off the top and the bottom. And they may have designed the deflection circuit so when it's working right, it doesn't go that high. You have to look at the mask on the set. It's something that trips up a lot of newcomers because they take it out of the cabinet and they start working on it and they forget what the mask looks like because they're not all the same. There's porthole TVs, in which case the whole screen should be filled. There are rectangular masks, which tend to be the earlier sets, where it's a rectangle over this, and it shouldn't be full width, and it shouldn't be full height. And then there's the double D, when the marketing folks got involved and they wanted to maximize the screen viewing area, while still being honest, so they do block out the top and the bottom, but the width goes all the way to the edges. I myself don't remember what flavor this set is. I need to go look. It's like with a lot of things that the last 5% takes 95% of your time. It's often no different with this stuff. What I'm more inclined to do, rather than to keep going over this and clipping out these resistors, which are all pretty close within spec, I'm more inclined to finish up the rest of the set. I did finish recapping, I think, the horizontal, with the exception of there are still one or two original mica caps, which I'm inclined to leave in for now. A few more resistors to spot check. There are a couple more original electrolytics down in here. Of course, I need to attach that more safely. Eventually, I do plan on taking both of those canned electrolytics out and more neatly mounting replacements for all of them instead of tacking them in around the set. Most of what is undone is stuff we haven't talked about yet. The RF, the IF, all the video, all this stuff. I will also tell you that I don't expect to see much change with that as well. And something that doesn't get talked about a whole lot either is that, yeah, it would be fantastic for every part that you identify that's out of spec that you replace, it gets a little bit better, a little bit better, a little bit better. The reality is you identify the gross problems, the problems that are just showstoppers, and then there's very little, if any, difference when you replace a whole bunch of stuff. So I could probably I will go through and replace all this stuff, and it may make barely any difference whatsoever. That's the unfortunate reality of working on vintage TVs and recapping them. Let's really get down in there. I don't know how well you guys can see it. That's one of the joys of replacing these is that they're buried. There's a bunch of stuff on top of them. It's hard to get at all the lugs, but if you make this out, this top one has 3 sections to it. There's a guy right here, and right below that is a 4th section. Now, curiously, and I think this will be good for us, there is a little metal mounting plate underneath riveted to the chassis. Usually there's just 4 slots stamped into the chassis and a square hole for the lugs and they feed through these twist lock tabs and twist them around, and that's it. For some reason, there's a subplate on these that's riveted. If we drill that out, I think these rivet holes line up with those adapter caps I talked about earlier. Somewhat controversial, yes, it will alter the original look of it. Well, this is what I'm talking about. I'm proposing installing. Replacing the can up top. Go back and watch my video on recapping. I explored a whole bunch of options. This is what I plan on doing. Once I confirm that those line up, I'm going to carefully move parts aside and get in there and drill out those rivets. I may want to do it from the top side. Oh, that's tough. Let's see, can you guys see that? Yeah, there's a rivet right down here. It's right next to a terminal strip. On the upper right isn't so bad. But to get any of them, I definitely have to carefully bend some stuff out of the way. You're going to be drilling a chassis. The best thing you want to do is have a wire get tangled around the drill bit. Or slip and damage some stuff. Yeah, that one's easy to get at. That one, maybe not. There are other ways to get rivets out, but I find drilling them from the side where it's mushed over is a lot easier than going in from the top side. Alright, get out a drill and see what we can do. I was mistaken. The bottom capacitor is also 3 sections, so you have a total of 6 electrolytics between those 2 cans. So what are they used for? Well, we already know 3 are in the vertical. And those are the 3 we've tacked in replacements for. 1, 2, 3. What are the others used for? 1 is used on the sink separator. Our sink is pretty good, so I don't think that'll make a dramatic difference. Another is used on the brightness control, which seems to work fine, so I don't think that's going to make much difference. And the final one is on the video amp. That may make some difference, but our video seems pretty good too. That's what I mean about diminishing returns. So we're going to replace all these caps. I don't expect it to make much difference. I'm doing it mostly for safety, reliability. I don't want anything to brush into this and short out. Alright, so how do I get rivets out? Nice, sharp metal drill bit. Somewhat low RPM. Get right in the center there. Drill a bit. Cut off some of the metal, then nail set and a little hammer action, and it's out. I already did the other one. I was able to bend the terminal strip out of the way, so I will need to now get these twist locks off, because the cap is on one side and the plate's on the bottom, so it's still firmly held in place. I've already cut the wires off, so there's nothing attached to it. So doing those twist locks should take care of it. When I do use those, I don't use my good tiny needle nose, because it's a good way to snap off the tips. I have a blunt nose pair somewhere around here. Here we go. These guys. These are great for getting in and untwisting twist locks. Either untwist them or just go back and forth and break them off. I'm not planning on reusing this for anything. Oh, and they solder down. Out of the 3 tabs, 1 is soldered. So, ugh. I'm not out of the woods yet. I'm going to break this one off too. So now, if I go to the top side and reach around, and that's going to hard to get to. It's a little bit loose. So, oh man, this last tab, I don't even know if you can see that. It's bent down that way underneath this cap. It's bent down and then big glob of solder to the chassis. Okay. And yeah, I know there's other ways to do it. I could try cutting it open from the top side and drill down holes from the top side and run wires through. Actually, it doesn't look too bad. That blob right there. Another good reason to use a temperature controlled soldering iron is, even though it's only 65 watts, it should be able to melt that. We're thinking, oh, you need a 200 or 300 watt iron or gun. No, because it'll keep pumping more power into the tip to get it up to temperature, so it will actually should do a decent job on that. Let's find out. Alright, I was able to break the solder connection with the iron. Now I'm trying to bend this tab up enough. There we go. I can get the pliers in there. And then bust it off. Alright, that should do it. Just reach around from the top. And there she is. A 20 at 450, a 10 at 450, and a 50 at 50 volts. There are the various symbols. We have a triangle, we have a square, and we have no symbol. This corresponds to the little legend on the side of the can. That's how you know what goes to what. And on the schematic, assuming it's accurate, they also have the same symbols next to the lugs. And because of that solder blob, this plate is still stuck to the bottom. And the one problem I've seen with using these adapter caps is sometimes the symbols on this don't line up with these symbols. Plus this is a 3, it's a little bit smaller. I think I might have some 3 section, but I don't think the holes line up. But let's see what else I got. I'm pretty sure this will line up with those. Oh no, it is a smaller style. Okay, hang on. Let's see. I think I have some smaller 3 sections. Four, 4, 4. It's 2. Aha. Whoa, I think that's what we want. And on the bottom. Yep, square, triangle, blank. So that's what we're going to go with. This hole should line up. I'll double check from the top side. Right, now I'm going to drill out the other one. And then we're going to select our replacement caps and get them mounted and get these installed and hook up all our wires and life will be good. I got the second cap out without any drama. It has 2 sections, 20 microfarad at 450 volts and a 60 at 350. Those out of the way is what we're left with. And yes, these mounting holes do line up perfectly with the adapter caps. I'll install those with some nice cap head stainless steel screws, and then the new skinny cap electrolytics. Just mount them like so, and then you make your connections down below. It's a nice, neat solution. Yeah, I know we're not restuffing the cans, we're altering the original look. Alright, so yeah, I have in the past, but here's a few things to consider about doing it. If you completely seal the new caps inside of this, a few things. One, if you ever need to replace one, you have to tear it all apart again. 2, if you think there might be a problem, you can't see the caps. You have to, again, open this up or test it from down below. With this, if a cap was to rupture, I would obviously see it. The top would blow out or something. If I need to replace it, I can very easily get at it. And finally, heat. You seal them up inside a metal tube, they don't get air circulation. Not that these will get really hot, but the number one factor that deteriorates capacitors is heat. If they're outside, air circulating around, they will run cooler. So that's another reason I've been using these more and more lately. To each his own. Do whatever you feel comfortable. Mount them down below. Restuff the cap. Do whatever you like. Whatever you want to do. This is what I'm doing. And there we have it. Nice, neat job. 6 new electrolytics installed. And that is going to wrap up this installment. When we pick up next time, we're going to wrap up the recapping and then talk about making final adjustments.